Okay, today inshallah we will just this medium link. I sent it for you, and we today will explain this code. I told you it's okay for me to provide you my code, but it doesn't work. All checker doesn't work, and it's not the perfect one. So I just when I found this medium and this code, I prefer to provide you this code because it seems better more than mine. So just today we will explain this code and try to figure out the structure of simple shell and everything about it, inshallah. Okay, the first thing, in simple shell you will have main.c or shell.c file, and this file will just include your main function. You know that we should have only one main function in our code, okay? So main.c or shell.c will have your main function, and the rest of the files you will create you will create another function without main.c, just as a function, and you will call this function in different places, okay? And shell.h will have the prototype of this function, of course, and in every file we will have shell.h, okay? So let's take it step by step. The first thing we have main.c. Is screen is clear or it's better now? Okay, I think it's better now. Okay, 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 great. And now the first file we have main.c file, and we said main.c will include our main function, and we know that main function is the entry point of your program. So that means your program will start. Yes, 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 don't worry. Okay, okay, uh, okay, to make sure, yes, I'm recording. Your main function is the entry point for your program, and that means your program start executing your code from this point, okay? So at the first thing, we have our condition if is 80 is equal to 1. We know that is 80, it's a function or system call. It's like a check if your program connected with terminal or not. What does that mean? Um, it's check also if it's in interactive mode. That means if your program connected with the terminal, and when you are writing a command, it takes this command from you and okay, and display some prompts for you. So wait, this is our terminal, okay? And now our shell displays a prompt for me. This is a prompt, so it displays a prompt, and it okay, it accepts any command from me and it executes this command, and this is called interactive mode. And this function execute if it is in interactive mode or not. So it's connected with terminal and take command and giving you the prompt and take commands and execute commands from you or not. So that's mean interactive mode. So we can say here interactive mode. Okay. um, okay, when your program interact with the terminal and display the prompt and take the command and execute it. Okay, so is 80 is a check if your program is in interactive mode or connected with terminal or not. Okay, so if it is equal to 1, that's mean it's really connected with terminal and it is in interactive mode. Okay, so when we in our case it is in interactive mode, we here have a function called shell interactive, and we are calling this function in this file. Okay, but if it is not in interactive mode, so it is in non-interactive mode. So what is the meaning of non-interactive mode? That mean your program is like connected with other thing, which mean like other stream, a file, anything else other than terminal. Okay, so non-interactive mode, like when your program connected with like file. Okay, so now is ATI is a check for us if it is in interactive mode or non-interactive mode, and both of those interactive and non-interactive, they are function. He created this function and just he is calling the function here. Okay, so let's go the first function, which is shell interactive. So if our is ATI return 1, so we go to this line with it shell interactive, so it's called shell interactive here. Let's go to shell interactive. The first thing we said that when we open our terminal, it displays a prompt for us and it accepts any command from us, and it takes this command and it executes this command. Okay, so the basic steps here for shell interactive. First step, displays the prompt for us. Display the prompt. Second one, like we can say it takes a line or okay, takes a line from you. Okay, takes a line or command line. Then we can say it tokenize it and execute the line or the command. Okay, where is anything? Okay, so here just here like start or define our variables, and we will talk about this. But just here, the first thing, he prints our prompt. So in its shell, when in here his shell, when he like start his shell, he like show you simple prompt and this side. Okay, here we have our prompt is root and this and this hash. But for him, he has simple prompt and dollar sign. Okay, so that's the first step, is to display the prompt. The second one is to take or to read the command line. So for the second one, he has a function called readline. Okay, and he stores the result come back from this function in this variable. So we have variable here, and this variable basically just stores the result from this function. So let's go to this function and come back here again. So our function is called readline, and this function basically just like takes the line or command line from the user, and like take it for the developer, give it to the developer. Okay, so for getline function, as we said before, getline function needs some parameters to work. If you need to call this function, it has some conditions or some parameters. So we have the first one here, it's line, which is like the buffer line, which we will store our line inside it or our command inside it. Like a container, we store our command inside it. And the size t for buffer size is just to store the size of our command line. Okay, but here it's he assigned the line with null and the buffer size with 0, just for like manually allocate memory for these two variable, because we should avoid memory leak. So here okay, here he calls the getline function and give it the parameter its need, like the line, which is the buffer it will where it will store the line or command line, and the container which holds the size of the command line. And the standard input here is like a standard, it says just you will take your line from the terminal. Okay, and at the same time he check, so he called the function and he checked for the error, because we know every step we take we should like check for the error. So he checks for if it's returned -1. I think he did the mistake here, because he says here if it's equal to -1, you should free and exit success. So I'm not sure if this part is okay or not. But he checked too for something called end of the file, which mean when I read from the terminal, which you say, let's say -LA. He mainly says here when he check for the end of the file, he means if you read all the commands and you reach the end of the command. So he check here for the end of the command, and if it's true, you will free the line and execute successfully. Why we are free? For avoiding memory leaks. And we execute the status was like execute successfully, but else we will freeze the line and print the error and execute with failure. Okay. Um, okay. So our steps here just he opened or like, defined the variable our function needs, and then he calls the function and they check for error. Um, and after that he just like if there is an error it executes with failure, but he also check if it's the end of the file, and if it's the end of the file he will freeze the line and execute successfully. Okay, and then he will return the line. Okay, our line now have it should have like our command. If I write ls-la, so it has now ls-la. So we will go back again here. So he called this function, and this function now have ls-la, which is like our command. So it store our command in this variable. So our variable which called line now, the variable called line have our command, which may be ls-la or any command. Okay, so then we come back to the next like step, which is split line. What is the meaning of split line? We know that any command we need to break it down into small pieces or small tokens to execute each one. If we like don't remember that, we said before why we need the string tokenization function, or why we need to break down our command into small pieces. Need to break down, okay, our command into small tokens, because if we just take our command like ls-la as a one piece, it just will execute ls, but we need to execute the flag -l and the flag a2, so like it will give us different results. So because of that I need to break down and take ls alone and -l alone to execute each one and give them the right result, because ls only will do something. Like if we said here just ls, it will display this result, but if we said ls-l, it will display different result, and if ls-la, it will play other different result, because it will give us the directory also, not just this result. Okay, so if we just like take our line as one piece, we will not make perfect template shell. We need to break it down to give us the right result. So because of that we need split line or string tokenization, or our function should like break down our command into small pieces or small tokens to execute every tokens individually. Okay, so because of that we call this function and we give it the line as input or as a parameter, which mean we give it our command as a parameter. And when we call this function and it gives us the result, we will save the result here. So let's go to this function and come back here again. So like this. That's it, right? Yes. Okay, this is our splitline.c function or file. We have here parameter, and this parameter which have our like the container which have our command, which is now ls-la as a one piece. Okay, so here we know that we will call string tokenization or string token function, and string token function, for using it we need to have some variables or like some parameters for it. So the first one we have here tokens, and we opened a space or allocate a space by malloc automatically in memory, and then we are checking here for like for if allocating memory is failure. So we have checked this condition, and if it's fail we should like execute with failure. Okay, so basically here just we um, okay opened our variable buffer size, because it's like our string tokenization. Okay, we will go here. We just here open buffer size, and like assign it to 64, because like we here allocated a space in memory but manually by 64. Okay, and this token we allocated it automatically by malloc. And we have another variable, it like called the token 2, and we will know what is the difference between tokens and token. Okay, so just when we opened or we used malloc here, we checked for error. For if there is any error we will execute with failure. And here token is the variable, or here that it is a variable we store the result from string tokenization function. So we give our function the line, and the line it is a variable which hold our command. And this macro, he defined this macro inside shell.h, and it should contain the dlim. If you remember dlim, it is like the mark. Whenever a string token will find it, it will cut our or break our command line down. So we can say ls-la. We said that how our string tokenization function work, when it see like how the function know I need ls alone and dash l alone. It just knows that by the dlim, because in the dlim you are saying to it, when you see a space, you should start to break down my command line or my line into small pieces. Okay, so if we have um, let's take any like string like hello world from C again. So if I specify my dlim equal to space, that means I'm saying to string tokenization function, whenever you see a space, start break down my line or my string. So it will come here, and it will find HELLO. So there is not these are not space, but it will come here and it will find this space. When it compares this space with the D line, it will find they are the same. So it will like start break down our function from our string from here, and it will like return back your hello inside the token. But in our example, it will be like a command or anything else. Okay, the second time it will start to scan again, and will say it's WORLD. They are not a space, and when will it come here, it will find it a space. So when it compare it by this, it will find it a space, or they are compatible. So it will start to break down our string from here, and it will like continue like that. So token, it is the variable which when our string token start like break down our command, it saves the result here. Okay, and this macro, he defined this macro inside the shell. Wait, um, okay, macros, where macros, okay, macros, and he defined this macro by space So whenever we see in our command a space or tab or new line, I'm not sure, I'm not remember what is this, but when we see any of these mark, we should start to break down our command. Okay, so when he puts execute, no, we are here. Okay. When he put this here, he is saying for string token, like we can just do this. Here he is saying for string token, I give you my command and I give you a mark. This mark may be a tab or maybe a space or maybe a new line. Whenever you see any space or any tab or any new line, you should start break down the string or the command and save um, the first command here. So let's just write this. Um, okay, maybe you just can, for example, our command ls-l a temp anything else. Okay, so what will happen here, string took will come and scan this command. Okay, so here this is our dlem here will be a space or tab or new line. Okay, so here it will scan for L, it's not a space, not a tab, not a new line. S, it's not a space or tab or new line. And here it is space, so it's one of them, so it will start to cut down the string from here. Okay, and it will save this ls in token. For the first call, it just will save the first token, not the all of them. Okay, so here token have the first command. Okay, or first token, and then he start looping over the token when we are saying while token is not equal to null. Why? Because token here is a string, it's array of string, which means it's array of a string. Now it has just ls. Okay, and we know that every string should have null terminator at the end, which means like this symbol. Every string for like C, for saying for C that this is the end of that string, you should put null terminator. Okay, so now we are the one who creating this array of string, and we didn't put our null until now. So because of that, wait, our while loop will continue to loop. Why? Because it's not equal to null. Why? Because we didn't put any null terminator or this symbol inside our string or array of string. So because of that, it will continue to loop. Okay, so we are here saying while token not equal to null, which mean it is not the end of the token. The first thing we check for comments. Okay, so here in this case, he just wants to handle if the user uh, write a comment inside the shell, because if the user write a comment, it's should display the prompt again. It will not even read the rest of the line. It just when the shell see the hash of the comment, it will start displaying the prompt again. Okay, without executing or without looking at anything else, because the comments, it's like as comments, he will not execute anything. Okay, so at the first okay, now our token equal a command, whatever this command. Okay, so we are checking if this command is equal to this hash. So I'm saying here, if it's equal to this hash, break the while loop, which mean go out from the while loop, end this while loop. Okay, why? Because we will not execute anything with the comments. We just will display the prompt again, like here. If we write comment, it doesn't do anything. It just displays the prompt again. And what basically is happening here, if you see any hash which indicate that what is coming after this hash is comment, just break, like go out from this while and display the prompt again. Okay. Maybe at the end of this session, maybe I can take this code and write comments inside it, or like a comment to uh, describe it. I think it's really better. Or maybe we can just do it now from here. We can use okay, we can use online C compiler. Okay. Here, okay, here we are checking for error uh, from a loop. Okay, here as this is the first string to call. Okay, and the okay dlim is the dlim mark whenever string to sees one of these marks, it should start break down the command line and sorry, and token now has the first comment only. Okay. Here we are looping over token. Okay, and here we handle the comment, which mean if the user write hash, that's mean okay, this is a comment, and the shell will ignore everything and go out from the loop and display the prompt again. Prompt again. Okay. But here, if it's equal to hash, it will just go out. But if it is not equal to hash, which mean like our command now, our token have ls or cd or any another command, which actually we can execute it. Here we are saying for token, the first position, I want to store like the value of the token now. Here, let's come here. The value of the token, we set the first command, which may be ls or maybe cd, sorry, or maybe the env or anything. So I'm just taking the value from here or copying the value from here to here. What is this? This is like array of string. I will like store everything inside this array, because I will return this array back to our shell interactive file, and I will use it again. So okay, look at the end of this code, we will return back tokens, and tokens here will be array of string holding the command, like tokens at the end of this code will be like ls dash l a and anything else. This is the like final version of tokens. So I will take these tokens and okay, I will use it here. Tokens, when I get like this is function return tokens, so tokens will be saved here, and I will use it with this function. So because of that, here we opened or we start our tokens, and I'm saying just any value enter the token, this token which is like a container. Okay, wait. Okay, we can say token is the container, hold the result from string toc function. Okay, and the tokens, it's array of a string. We will return it at the end of the code to use it again in another function. Okay, so I'm staying here, or like we can say the translation of this line, whatever will be stored inside this container, put or like copy it here. Okay, so maybe we can just like add something called translation. Okay, whatever come inside token, store it inside um, array of string called tokens. And we know why, because we return it back and we will use it somewhere or in other place. Okay, and here I plus plus, that's mean like just I'm not using the first index of the array, I'm using the all index, like which mean okay, I plus plus, like I'm saying open another spaces inside my array string to store or to be able to store the rest of tokens. So it's just like my tokens now will be equal the first command. Now it has the first command only, like ls. If I didn't say I plus plus, it will be like closed on that. Like even I have another comments, I can't put it here because I didn't increase like the number of spaces inside my array. Okay, so I'm just increase the number of spaces here to be able to hold the new comments. Okay, here, okay, if buffers, if I bigger than a buffer size, we opened our buffer size here. um, Buffer size, which is like variable contain the size of our like command, which is line. We broke it down. It has the size or spaces inside the memory. Okay, so it's we opened here manually by 64. Okay, but maybe our command will be more than 64. So if we didn't like update the value or the size inside the memory, we will have memory leak, or we have error, or our program will give us a error or a crash. Why? Because you opened a specific space and it require like bigger space or much space. So because of that, we just here updating the spaces inside our memory. So we are checking if the space is not enough, or our tokens, or I hear that like our string now is like bigger than the space we opened. And if that's like if this true, we will update our size in memory, but we will here like double it. So like we are saying just 64 plus 64. Okay, so here we are checking if the space in memory is not enough. Okay, enough. Okay, and if it's true, here we are updating the space in memory by doubling the size. And then I'm making reallocation again because I'm doubling the size, so we have to make reallocation after doubling the size. And here I'm just checking for error if realloc fail. So we are checking for error of realloc, and if there is an error we will just print this and we will execute with failure. And here it is a second call of the function, but here it's not just a second because it's inside the while loop, so it is like the sequence of call of the string tokenization function, sequence of calls of string token function. Okay, so in this sequence of calls, string token will start like break down all like if we say dash l a n v anything. um, this sequence, it's just the first call, it's just break down the first one, but in the sequence of call it will break down everything, so all of our command line will be broke down, and it will be stored here. Okay, and then like after we broke down the all line, sorry, the all line, yes, the all line or all command, so we said that any string should end with null, because in C basically how C or the program knows that this is the end of the string by a specific mark, and it's like null, this mark. So here I'm assigning my tokens of I, like after tokens now take ls dash l and a, so my commands or like my tokens inside the tokens now. Okay, and at the end I just put null here to like say it is the end of my string or my array of string, and I return this array of string now. Okay, so is it clear until now? uh, okay, yes. Yes, I need to ask Trace if she like knows system calls or not, because she is cohort 14, not with us. Mm, okay, okay. Um, so now we have our tokens, which is okay. We are here. Okay, I have we have now our tokens, which is like a string of array, and like this form, like this. So and I like args now will be look like tokens because I'm saving the value of the tokens inside the arg. So args now you can just like move this and say it's args now. So args now have our command and it's broke down into small tokens. Okay, and here after read the line and tokenize it, I will execute it by execution function. And the execution function, of course, will take a parameter, and this parameter is our array of string, which is so the input of execute function. It says this is array of string. Okay, so let's go to our function execute args. Okay, uh, okay. The first thing we just should know that commands in a shell have two type. The first one built-in commands. Okay, built. And the second one like files. So what does that mean? Built-in commands. That commands come with shell itself. Like shell itself has these commands and has everything about these commands. Or you can maybe say it's developed from shell itself. But files, that mean there are other programmers or developers Is it someone like raised his hand, or it's okay? I get the doc of this class. Uh, I didn't get him, Anthony. Sorry, Emmanuel. What is the doc he wants? Okay, I think. Okay, I will send it again. It's okay. Okay. Okay, we have two different type of commands. The first one is built-in commands, and built-in here, which mean like shell itself has these commands. But files, that mean there are another programmers or developers. These developers create this function and create files for this function inside the shell. So in specific paths inside the shell, these files are exist. So these files is not like from shell itself, but they are from other developers and they put it in shell to like make everything on, easy for us. Okay, so now we have two type of commands, one of them built in and one of them files. So to execute our args or our command, we should at first check if these commands are built in, or your call end in 10 minutes. Are you like Emmanuel, are you create this call with time? Okay. Hmm. Okay. Okay. So we have to check at first, is it a command built-in line, or it is the files created by someone else. Okay. So at the first, we have here our list. This list have just this. We will we will handle in this program or in this task. We'll handle just some few built-in commands like cd or env or help or exit. Okay. This is our built-in function list. To Okay, we created this list now, and this is a pointer function, and here this function will point to, like we said, built-in function. It's function inside the shell itself, so it's a point to the place where this function exists in shell. Why? Because if this we will make a comparison now. If this comparison match with one of them, it will go to the place in shell where this function exists, and it will execute it. Okay, so this function just a pointer, just like a delivery man. When it match your comparison match with one of these function, it will go to shell and say for shell, please execute this function for me. Okay, so as the first here, we check if our arguments equal to null, which mean we don't have any input, we don't have any command. So we will return -1, which means just we will like execute the end the problem. Okay, uh, I'm checking here for this args, which I get it from string tokenization function. Okay, so if it's not equal to 0, so there is a command here, but I'm checking here, sorry, I'm checking here in index 0, which means just the first position in our argument. Why the first position? Because I just need the first position now to check if our first command, it will check if it's equal to cd or env or help or exit. So now I'm checking if it's equal one of built-in function or not. So I just will check this one, position 0. Okay, so we have here for loop, and this loop just to loop over this built-in list, and it will loop over the arguments too, and it will check to here this function to make a comparison between what, it will make a comparison between our argument index 0 and the built-in function list. Okay, so this is our argument, and this is the position 0. Okay, this is position 0. So it will make a comparison between this position and this list, and it will check ls is equal to cd, sorry, this list cd, or ls is equal to anv or help or exit. Okay, so if it is equal to 0, which means there is match, so my command is cd or env or help or exit, one of them. If it is equal to, like, there is a match between them, we will return a pointer function um, holding my command, which means I'm returning back to this function, and now I'm saying I'm pointing, like, let's say my command here is cd, so I'm going back here and point here, which means I'm saying to my delivery, go to cd or to shell and say to shell to, like, execute cd function. So here it just return a pointer function to the place inside the shell which have cd function to execute it. Okay, and but if it is not a built-in function, which mean it's a file, it's like someone creates this file and put it somewhere inside shell, so we will have something else to do. We will create a new process to execute our files or arguments, which is a file in actually. Okay, so here this is like the function which, when our command not its built-in function, it's a file. So now what will happen to execute this file or this command? The first, I will make fork, so I have bid and status. I will make fork to make to have a child and a parent, because we know execute function, when I use it, it's like remove every code after it, and we want to execute everything. So just because of that, I made the fork. And here I'm calling the execute function to execute argument 0 and the list of arguments, and I'm checking of the first, like, at the same time I'm checking if there is any error. So if the okay, I'm sorry, I made the fork, and I'm saying if I am on a child process, because we know that we okay, no, okay, again, Emmanuel, I'm sorry, I didn't get you. Okay, so it's okay, uh, okay, here we just have our fork function, and we are calling fork because we should have a child process and parent process. In a child process, we will execute our commands. In parent process, we will make it wait for the child. Okay, why I'm using child and parent? Because we know execute function, it overrides the old program, which means when it's when give you are giving the execute function a command to execute, it will, like, clear everything after it or ignore every code after it, so you will, like, miss some of your code in program. So because of that, we need for. And here I'm checking if bid equals 0, which means I'm on child process. So if I'm on child process, I will execute my command line or my commands. Okay, so here I'm calling the function, and arg0, it's the name of the program, and then I give it the args, which is the parameter for the function. And at the same time, I'm checking if there is any error. So if there is any error, I just will print there is error and execute with failure. But else if bid bigger than 0, um, so, like, there is an error in forking 2, so I'm checking for if it's, sorry, id less than 0, which means -1, so there is an error. So the first thing I'm checking if I'm in child process. So if I'm in child process, I will execute my command. then I'm checking if there is an error in fork, and if there is an error I just will print there is an error. Else, so I'm on the parent process, and if I am on the parent process I just will make the parent wait for the child. Okay, but here we have like different like there is a command sorry, there is a status, bid and status, and this is standard. And mainly this standard mean if the child, like I'm making the parent wait for the child process, even the child process is buzzed, like there is a signal sent for him to kill the child or to pass the child, or the child stopped, or the child terminated. Whenever happened to the child, the parent should wait it. Okay, and the second thing here, this is standard check that just if the child executed normally, which means the child take the command and it execute it and terminate the program. Okay, and this one check if the child process terminated by signal, which means while it's doing the process or perform the process, there is signal come and kill the child or pass the child or doing anything. So I'm here while it is not terminated normally, and it is like there is no signal sent to it, just return -1. So that means there is an error and I'm ending the program. Okay, so this is like the new process, and we said the new sorry, this is like the file or the code for executing the files, not built-in function or built-in commands. We just will make fork to have a child process to execute the commands and to have a parent process to wait for the child. Okay, and yeah, I guess we should go back to interactive. Yes. Okay, so now execute args. It takes the argument, which array of string of tokens, and it return like integer number, indicate if there is a failure in execution of the commands or it is executed successfully. Okay, after that, like now I execute the commands. So after that, for avoiding memory leak, I should free the line and the arguments. And then I will check for the status. If the status bigger than or equal to 0, which mean like my commands executed successfully. So I just will exit with the status. Whatever the status come back from the execute function, I will put it here. But while status equal to -1, which mean I failed to execute my command, here this while loop mean display the prompt again and like repeat all this process again. So that's mean if there is a failure in execute the command, like repeat these steps again, like print the prompt again, call this function and read the line and put it here, and call the split line function and like break down the line into small pieces and put it here, and call the execution function and put the status here, and repeat everything again. Okay, this is for okay, this is for interactive mode. It is okay or not? Okay, okay, let's continue and like left this question at the end. Okay, this is shell non-interactive mode, and we said non-interactive mode, which mean your program not connected with the terminal, but connected to other stream, which may be a file or anything else. Okay, so in non-interactive mode, we will repeat every steps, like we have line and args and status too. What is the main difference? Like split line, it's the same, and execute arguments is the same, and we will freeze the line and arguments and end status with the same too. Just the main difference between them, it is read here read stream, there read lines. Why? Because there sorry, get line function, there I'm reading from terminal. So for reading from terminal, I should use get line function. but here I'm reading from stream, which means I'm reading from file. So I have another function here to use, which is get char function. Okay, so I basically here like have my buffer size and assign it by a number, which means also I just allocated it manually. And I have the line, which is a buffer to store the line from the file, and I'm opening a space or allocate space automatically by using malloc. And I have here the character, because get char, which means you are getting only one letter or one char. So I will like save it in this container. Because I opened or I used the malloc here, I'm checking for error in these lines, like if it's equal to null, which means there is a failure in allocation space in memory. While one, like which means while it's true, or this is an infinite loop. While one, which means it's always will be true. Okay, so this is infinite loop. Character equal get char. Get char here it is a function which you will read from stream, and it will get only one letter or one character. Okay, here I'm checking if the character equal to end of the file, which means this is letter which I get, it is the like the last letter in the file, or there is nothing after this letter. If this letter is like the last letter, just freeze line and execute successfully. Else if this letter equal to new line, so I'm now I skipped or I finished the first line and I'm in new line now. What I should do? Here's line of the line here, which is like we said, the buffer we opened to store like our lines from the file. Okay, so if it's equal to new line, that means it is the end of that line, so I just will put null, and we return line again, we return line. Okay, else here that means it's not a new line and it's not the end of the file, it's any normal character. Okay, that means save this character inside the line. And I plus plus here it's like keep open spaces inside the line for new characters. Okay, and here I'm checking again if the buffer size I opened is not enough space in the memory. So if that's true, just I will duplicate or I will double the space, and I will reallocate again because I doubled the space. And here if null, if line equal to null, here I'm checking for error in reallocation. So I will exit with failure. And basically that's all, everything in this code. Here just the shell library he used and the macros he defined, like define Tokenization, which is a dash, a tab and space and a new line. And the prototypes here he used like interactive and non-interactive for a shell, and read line and split line. Here I said that we will create files or many files. These files have our function without main function. This is only the function, and we will put prototype of this function here. So here he put the prototype of shell interactive function and execute argument function and shell non-interactive function. And this is the built-in function. He put it here. Okay, and I think that's all for this medium code. So maybe